Altair Inspire Cast is a powerful new tool for optimizing your casting designs. We start by opening a CAD model. In this case, we will be setting up a gravity casting simulation. In this first step, we assign part material properties and the direction of gravity. In this case, we will use a grade of cast iron and align our gravity direction normal to the bottom surface of the part. Next, we set a gate location, size, and shape. Here we will put the gate on this face of the part. Now we need to define our secondary mold components, and Altair Inspire Cast makes it easy and efficient to do so. We will create a core for the complex internal geometry of the part and define a mold. Using the basic process setup, we will determine how to control the flow of material into the part. We will use an initial velocity for this part. Finally, we run our analysis. We'll run both a filling and solidification analysis with an element size of 2 millimeters. With our analysis complete, we can now look at the results, which are split between filling and solidification. First, we analyze the filling phase. We understand how our part will fill using dynamic animations, clear visuals, and accurate results to check for defects and issues before physically pouring a casting. Next, we analyze the solidification phase. There is a minimal amount of internal porosity. However, there is a substantial amount of pipe shrinkage or sink on top of the part. This defect would be unacceptable, and we will need to address that issue. With this knowledge, we return to the initial setup tools to make a few modifications to our casting design. First, we start by creating a runner system for the material to more accurately represent what we will pour in the real world. This is done using Altair Inspire Cast's powerful and comprehensive geometry manipulation tools. We now redefine our gate location to the top of the runner we created. We will also add a few additional components at this time, specifically a chiller and a riser. Our chiller block will be placed on one side of the casting. Our riser will be placed on top of the casting and will be wrapped in an exothermal sleeve. This should help us prevent the pipe shrinkage defect in our final casting. We use the same controls as before to define our flow characteristics, as well as the same element size. And now we run our analysis again. With the addition of a runner system and a riser, we can see the part still fills just fine. We can also see that our riser has removed the pipe shrinkage from the top of the part, thus solving that defect. We can now proceed forward with the knowledge that we will have gained using Altair Inspire Cast to make informed and upfront decisions to save time and money in the manufacturing process.